Hello IBSL2. This video is on quadratics. What is the solution, how quadratics are symmetric, using the quadratic formula, and the discriminant. So first, realize the axis of symmetry equation is given to you. They give you the equation of standard form, and they give you the equation of axis of symmetry. Remember what that equation means. So if we have a parabola, the axis of symmetry is the line that is going through the vertex. So it'll give you the x value of the vertex, and it cuts the parabola in half. So every point value is symmetric. So if you can find this value here, you can use a reflection over the axis of symmetry to find the value on this side. So just remember what the axis of symmetry formula means. Again, it's going through the x-axis of the vertex, and allows you to cut the parabola in half. The other formulas we're going to be talking about tonight is the quadratic formula. We're talking about solving for the solutions. You can always use the quadratic formula to solve for the solutions. Remember what a solution is of a quadratic formula? They are the x-intercepts if they're real. So solutions are real. If they're real, they're x-intercepts. Solutions are always the roots as well. So the quadratic formula, if it turns out our parabola does not cross the x-axis, it could have complex roots. So have a real part and an imaginary part. So if our parabola vertex was going up here, the roots of this parabola would have an imaginary part. So you would have to use the quadratic formula to find that. And our solutions can be found, the type of solutions can be found using the discriminant, the b squared minus 4ac. Notice where that is in our quadratic formula. So remember, if your discriminant is a negative number, then you would have a negative number under the quadratic, under a square root. So if your discriminant is negative, if it's less than 0, then you're going to have imaginary solutions, imaginary roots. If it's a number greater than 0, then you're going to have real roots. So if it's a number that is positive, they could be irrational, but they will be real if it's a positive number. So you'll have real roots. And in particular, 2. Remember, they always come in pairs. So if it's less than 0, 2 imaginary roots. And if it's greater than 0, 2 real roots. And lastly, if your discriminant is equal to 0, then this portion under the square root is 0 and it's gone. So you end up having only one real root. And if you remember from Algebra 2, that was called a double root. And that means that vertex will actually be on, it'll be the real root, the double root, and it'll be on the x-axis. Okay. So just bringing back that knowledge from Algebra 2, what a solution is. And the power of the discriminant will tell you what kind of roots you have. Our first question here is an IB question, and is telling us our function, it has p times x minus q times x minus r, and part of the graph of the function is shown below. And it gives us that it passes through the points negative 2, 0, 0, negative 4, and 4, 0. So it's given us the solutions and the y-intercept. our values of Q and R, remember when you see this in this form, this is giving you the solutions. Here it's in the factor form, and remember your solutions are when the function is equal to 0. So in this case, if we set our factor of x minus q equals 0, we can solve for q to see our solution, and x minus r to 0, we can solve for r to get our root. They already gave it to us, so it's just a matter of understanding what this is given and realize what they're asking for us. So they just want to know our q and our r. So in this case, they are our roots. We don't have to solve. They already gave it to us. So we realize that q is -2 and r is 4, or vice versa. They'd have to accept either depending on how you solve q and r. But these are they're asking for the solutions. They're asking for q and r. So q is -2 and r is 4. The next part is asking us for the equation of the axis of symmetry, and it looks like it's cutting right through at 1. To verify that, we could use our two solutions they gave us to make sure that equation is right if x equals 1. And what you can do is to find the midpoint between the two solutions, and so that would be 4 minus -2 divided by 2, so that would be 6 divided by 2 would be 3. So the midpoint would be this value right here, so 1, 2, 3 and 1, 2, 3. So it does appear that the axis of symmetry is x equals 1. So using your knowledge of the roots, they have to be symmetric, you can determine your equation of your axis of symmetry. There's probably several other ways to do it, but that might be the fastest. So realizing that the midpoint would have to be 3 counts away from both of the roots. To find our value for p, we're going to use our equation to help us. So we know the roots, and we know our value of our y-intercept. Our y-intercept is 0, -4, and our equation is y equals p times x minus q times x minus r, which we already found. So we know our equation would be p times x plus 2 times x minus 4, and we can use our knowledge of our y-intercept to find p. So I can plug in this point of 0, -4 to find p. So -4 for y, and then 0 for x. So 0 plus 2 is 2, 0 minus 4 is -4. So -4 equals p times -8. So p would be 1/2. Okay, let's look at another problem. And this IB problem is asking us for the quadratic equation, the possible values of k again, and they tell us it's 2 equal roots. So here we have the quadratic equation kx squared plus k minus 3 times x plus 1 equals 0. And there's 2 equal real roots. So in this case, we know our discriminant is has to be greater than 0, plus what else do we know? What does 2 equal real roots mean? That's right, two equal real roots must mean that our discriminant is 0. So the real mean would be greater than 0, but equal, two equal real roots means the discriminant is actually 0. So let's start by setting the discriminant equal to 0. So remember the discriminant is b squared minus 4ac, and again that's given to you in your formula packet. Here this is our ax squared plus bx plus c. Our a in this case is k, our b is k minus 3, and our c is 1. So it's kind of strangely written, but it's equal to 0. So our b again is k minus 3 squared minus 4 times our a, which is k, and our c would be 1. And we're going to solve. So go ahead and multiply this out and solve for k. So when you solve for k, just multiplying through and then factoring and setting each factor equal to 0, you would get k equals 1 and 9. Those are the possible values of k. Alright, for that was part A. So part B, it wants you to write down the values of k for which x squared plus k minus 3x plus k equals 0 has two equal real roots. So again, we have b squared minus 4ac equals 0. And the part that is different here, b squared is still the same, and but instead of, so a is 1 this time rather than c, and c is k. So the problem turns out to work out the same, because b is k minus 3, and then you have 4 times a of 1 and c of k. So once you see that, you can realize that you've already completed that arithmetic, and you can say that my values for k for this problem are going to be the same, and k is equal to 1 and 9. Okay, so sometimes they will see if you're following what you learned in the last part to answer the second part of the equation, the problem. Here's a couple questions I want you to go ahead and try. The first one, consider two different quadratic functions of the form f of x here, and then graph each function has its vertex on the x-axis, and find both values of q, and follow through on these problems. And then for the second question, it wants us to find values of k when it has two equal real roots. There's that again. And then it has a trig part to part B and C. So go ahead and try that and then bring it back. Okay, so for the first question, it wants you, it says that the vertex is on the x-axis, so you have to realize that means if its vertex is on that, that means the discriminant is 0. It's a double root. So you set the discriminant equal to 0, and you solve for q, and it would be q is positive 20 or q is negative 20 of the two values. Then it asks you to, for the greater value of q, solve for f of x. So our greater value of q would be positive 20, so you plug that in. So a positive 20, so minus a positive 20 would be minus 20x, and then solve for f of x, so solve with the solutions, and you get 2.5. Then it wants to know the coordinates of the intersection of the two graphs. So you set the two equations equal to each other and solve for x. X is 0, and you can plug back into either equation and get y is 25. So they intersect at 0, 25. For the second problem, we set the discriminant equal to 0 and solve for k, and you get k is 4 and negative 4. For part B, you use your trig identities to show that the new equation. For part C, you then set the function equal to 0 and solve, and you get one distinct value of cosine theta of negative 1/2. Then you solve for theta using your 30, 60, 90 and your knowledge of the quadrants. Our last part, you're going to be using your sketch to find what